Here, we're going to solve this matrix equation and find values for the variables. We see the left side of the equation is going to be a 2 by 2 times a 2 by 2 matrix multiplication, which will yield a 2 by 2. And we have values here for all of these. So we're going to go ahead and work out this matrix multiplication, see what we have. So across the rows, down the columns. This 2 by 2 is going to give me a 2 by 2. So 1 times m and 2 times 4. So this entry will be m plus 8. Let's move across the columns. So across the first row, down the second column, 1 times 0 is 0, 2 times n. So we're done with that first row. Second row, 3 times m, and 4 times 4 is 16. So second row, second column, 3 times 0 is 0, so we just have the 4n. I'm going to rewrite this right side. So we did matrix multiplication on this left side, and this is what we have. We're left with this 2 by 2 equaling this 2 by 2. So we have equivalent matrices. When we have equivalent matrices, we can set up equations stating that corresponding entries are equal. So m plus 8, which is first row, first column, equals 10, first row, first column, and so forth. So 2n equals negative 6, 3m plus 16 equals 22, and 4n equals negative 12. So I have 4 equations here, but I really only have 2 unknown values. So I don't need to solve all 4, I just need to solve the minimum number of equations in order to get what I'm looking for. So here this m plus 8 equals 10. We can subtract 8 from both sides. M equals 2. And we could, if you wanted to, plug it in here. 3 times 2 is 6. 6 plus 16 is 22, so we're still good on that front. Down here we can divide both sides by 2. N equals negative 3. And if I was to plug it in here, 4 times negative 3 equals negative 12, so we know we're still good on that front. So we have solved this matrix equation. I used matrix multiplication on the left side, and then I used equivalent matrices to set up equations, and then I solved the equations to find the values of my variables.